Hi and welcome to our demonstration today. My name is Jordan Williams. I am the Azure Stack Technical Lead for Riviera, and I'm here today to show you through some of the features and functionality within Azure Stack. I'll be showing you through the deployment of a virtual machine, including the SQL Server application build out on top of that, all fully automated from Stack. And then later on I will show you through some hybrid deployment configurations and some hybrid models that can be achieved within Azure Stack and leveraging Azure Public Cloud as well. So without any further, let's begin. I'll start with coming through to the marketplace here. And if you're a user of Azure Public, then all of this should be fairly familiar to you. So here is our menu, from which we can choose to deploy any flavor of virtual machine that we have syndicated through from Azure Public. In terms of our SQL options, we can see here that we have SQL Server 2017 Developer, Express, Enterprise, and Standard, all on Windows Server 2016 to deploy. Today we're going to keep it fairly simple and deploy the free licensed 2017 Developer SQL on Server 2016. So we click the tile and we'll read very carefully through our terms and conditions, and then once we're comfortable with those, click Create. And here is the first blade whereby we'll enter in some basic settings such as a name for the VM, a name for the user, passwords, etc. So you can see our complexity and validation is built right into the form, just like in public. And we choose our subscription to deploy it under, and a resource group name, and the location being the Wellington data center where our scale unit resides. And now we can choose from a list of common Azure Public VM sizes. So by Azure Public VM sizes I mean that these VM sizes are in direct correlation with the VM sizes that you'll see available to you on the public cloud option. So you should be familiar with these if you're using Azure already. If you're not, never mind. There is very good documentation online to help you make up your mind and make your decision as to what the right size is for your workload. Today we're going to keep it fairly modest. We're going to do a A2 standard. On the next blade we can configure all of these various settings such as storage account, virtual network settings, our subnets, public IP addresses should we choose to deploy one with our VM, and what are our network security group or virtual firewalling configurations. Now if I knew nothing of networking and I still wish to deploy a SQL Server, Azure Stack and Azure have made it very simple for us to do so. With the default settings we'll get everything we need to get off the ground. However, if we so desire, we can go in and modify these settings as we so choose, such as the virtual network, use the address space and subnet ranges, etc. Or we might want to, for instance, change some of the network security group and firewalling port allows inbound or outbound. Here we can choose to deploy within an availability set, meaning if I deploy two VMs with a common workload or purpose into an availability set, then I can give myself some peace of mind in that when we go through a patch and update that these servers will be spread across different physical servers, so will not be patched at the same time. We can enable our guest OS diagnostics here, and here we can choose either a generic standard diagnostics account, or if we've got a diagnostics bucket, for instance, where we might be pulling logs out of all the time for analysis, choose a common one that we reuse for all of our VMs. Today we're going to keep it very standard and just go with all of the defaults. And here we get some connectivity and presentation options. Do I want to present my SQL Server to the public internet? Probably not. Do we want to present it to the private immediate network, the virtual network within which my SQL Server resides, or just present it to itself? I'm going to go ahead and choose private today. Actually, we'll do public and then we'll connect to it. We'll show you through that experience too. And then we can choose a port. I'm in the habit of choosing a non-standard port where possible for SQL, because port 1433 is one of the more commonly port scanned and abused ports on the internet. We have an option to choose whether or not we want to configure SQL authentication or stick with Windows native authentication. What's our storage configuration like? Would we like to optimize it or change the size of the data disks? Let's just update that to transactional. And here we can choose what our automated patching schedule might look like. This is quite handy because it allows us to set an automatic SQL Server patching schedule for the time of day or night that we envisage our business will not be requiring the use of the SQL Server. So with that being said, we'll keep it at Sunday, relatively early in the morning. Maybe we can kick off at 12, and maybe we might tolerate up to 150 minutes of downtime. Automatic backup. Now I can see that this has got a padlock here. I believe this is a future state feature which will be released upon the convergence of the Azure backup resource provider into the Azure Stack product. And we can choose whether or not we need to use Azure Key Vault integration so that we can use Key Vault for our authentication and authorization, but today we're not going to. We'll just keep it quite simple. And now you can see Azure Stack has validated my parameters. It's quite happy with my template, and therefore I'm allowed to go ahead and deploy it. Now that'll take a little while, so I'm going to pause the demonstration at this point and come back to you very soon. Okay, now that our SQL Server is deployed, we can take a look through the deployment and have a look at the timings. So back to our SQL resource group. Now just a quick note, resource groups are a very good way to classify objects which all belong to a common cause. So the term used in Azure world is objects with a common life cycle. So all of these objects contribute to a single cause. It could be a single set of objects in virtual machines which all contribute towards a system, like a CRM system or a user acceptance testing system. It's a very good way to group these resources and make sure that we protect ourselves from deleting items which belong to other bits and pieces. Also, it allows us to do updating at a cadence without cross-contaminating into other products that we don't want to update at that given point in time. So just a quick note there. We can have a little look at our deployment status here. See, it succeeded. It took 28 minutes and 40 seconds. And we can drill down a bit further and have a look at how that went for each component. And there are our template parameters there. 28 minutes and 40 seconds is not how long it's going to take to build every VM. Simply the SQL VMs take a lot longer due to the scripted installation of SQL on top of the virtual machine after it's deployed. So don't expect that as a normal timing for a VM deployment. The others are usually less than half that. And if we click on our VM itself, we can see it's automatically provisioned its public IP address, and we can see the DNS name label that I've manually added onto it there just for ease of use. And we did deploy it with Windows Auth. I've since gone in and configured a single SQL Auth account for our use in connecting to it remotely. And let's just show you through how that might look. So if we go to connect to a database engine, I've put in our DNS label there, comma port name, a non-standard port. There's our external user that I've created for external administration. And we can go ahead and create a new database. And it's a test database. Provision. No problem at all. Do anything we like from SQL Server Management Studio remotely, although of course we'd usually recommend that where possible do not expose your SQL databases to the internet. So that's a SQL Server deployment, fully automated, and that part is a wrap. In the next part of this demonstration, I hope to show you through some of the hybrid opportunities that we may be able to encounter with the use of both Azure Stack and Azure Public Clouds. Alright, now we're going to show you through a Azure and Azure Stack configuration where Dan's Finance was able to achieve high availability, or DR if they so choose, between the two clouds, Azure and Azure Stack, for their website. So let's just jump right in and have a look first at the website. This is a very simple flat website that we've built just for the purposes of this demonstration. So nothing very special here, but the special part is how is it supported and how is it hosted and delivered. So here is Azure Stack. You'll notice first that it looks a lot like Azure. If we kept the same color scheme, it looks almost identical. We'll keep it different for the purposes of the demo. And first thing you'll note is that we're not just running this website off a VM, we're running it off a virtual machine scale set. So the purpose or mission of a virtual machine scale set is for the scale set instances or VMs will all be delivering and supporting a common workload. So in our case it's an IIS site with a website hosted on that. So they're all just a group of machines with a common purpose, and we can scale these up and down and left and right. So what I mean by that is we can scale them up and down in terms of size, and we can scale them out in terms of count as well. So very easy to change the size of the VM profile in a scale set. We simply choose our new size and reallocate. So moving on, the purpose of this demo is to demonstrate high availability. So what I'm going to do next is I'm going to stop and deallocate the scale set. But first let's have a little look at how it's delivered locally. So within our scale set we've got a load balancer. The load balancer basically watches both VMs in the array and only allocates requests to those VMs. So our load balancer has got a public IP address on the front end, and we can see that we've also got a back-end pool consisting of our two VM instances serving up the web address. We've also got the health probes, which I've just briefly described, which keep monitoring each website on each VM to make sure that it's up and that request should be genuinely passed back to that site. So without further ado, I'm going to now stop and deallocate our VM scale set, and then that'll give us an opportunity to observe the automation magic that's occurring behind the scenes, and we'll see why very shortly, that why we're able to achieve constant uptime even though we've stopped and deallocated. So the site will go down. It'll go down for about 5 minutes while the automation happens, and I'll pause the video for that time. Okay, so welcome back, and now as the administrator of Dan's website, I've received an email saying that our web app has failed at 4 locations for 5 minutes. So this is from our Application Insights account. Our Application Insights are continuously watching our Traffic Manager URL to make sure that our website's up and running. And if it's not up and running, then it does something. So what does it do? Well, the result of that you can see here. So here is our virtual machine scale set in public this time. In Azure Public, we've got the same footprint, the same virtual machine scale set with the same load balancer configuration, and it's for some reason these two instances have started themselves up. Now let's have a little look at why. So we'll begin with the AV monitor, and here is the availability monitor we've configured. And we can see it's not looking too happy or healthy with the red dots showing up there. It's a sign that we've got a bit of a problem. And if we go into edit the test, we can see that it's testing from 5 locations, these 5 here around the world. We're looking for a HTTP response of 200, which means OK, and give us an alert in the event that it fails at 4 out of 5 locations around the world. So you'll see that it's started to come back up now because our virtual machines in public have started up. But what does it do when it can't? It uses this webhook here to call on our Azure automation account to perform some actions. Let's have a look at that. So here's our Azure automation account, and we've created a runbook here, which is what you saw being called by the webhook. And this runbook's called Start VMSS. And if we just have a little look at the contents, what we've done here is we have used a application ID and key from an automation account to generate an authentication header token to put into our REST API call. And our REST API call simply just runs a command against our virtual machine scale set. So we can see it's talking to the resource group. Here's our scale set name, and it's asking it to just simply start here, as you can see. And the result of which is that our virtual machine scale set starts in public, and we can see that our amazing new website is running happily along in public. So that's not all. There is a little more to the story here as well. So one of the other questions that gets asked when regarding DR compliance and DR success is how do we keep our DR content in tune with what our actual content is on our live website. So consider the scenario where our DR site's been down for 12 months, and in that time we haven't needed to use it. It hasn't been updated, but our website has in the meantime. So to respond to that, we've created this is a custom script extension. So the purpose of a custom script extension is to execute code on a VM or a VM instance in a scale set each time it starts or each time we ask it to update. In this case, I've asked it to run this PowerShell script here, which is called install website v1.ps1. And what that does, let's bring it up in Visual Studio Code here so you can have a look. It basically downloads a website from our blob and extracts it to a directory, and then it installs all of the IIS roles required. It imports the web administration tools for PowerShell and then uses those tools to create an application pool. It also then creates a new website using that web root, which has got our actual content extracted into it. And then it'll shut down and restart the VM, ready for productivity. So what does that give us? That gives us some assurance that if we add another instance to our scale set, so if we get a little bit too busy for the 2 instances that are already running, we can add another instance and we can know that it's going to source in our IP for our website. It's going to source in the website itself and the engine it runs upon, and we're not going to have to touch it administratively once. Before we go today, I wanted to give you a quick overview of Traffic Manager. So as I described the load balancers before, each of those load balancers sits in front of the instances. In front of the load balancers themselves, we have Traffic Manager. Now, what Traffic Manager does is it watches both of those load balancers URLs, and as soon as one of them stops responding, it stops sending them requests. So what it does is when an end user requests this website from our Traffic Manager, Traffic Manager responds with the URL of the load balancer that's available. And should we turn one or the other off, it's going to basically load balance between those two geographically. It's an excellent tool. Thoroughly recommend it for any hybrid configurations that you might want to deploy. It's very low cost and it's very effective. Now, one last thing that I'd like to show you that you may be thinking about is why aren't we just running both virtual machine scale sets concurrently all the time? Well, I guess the answer is that that may be desired in some circumstances. It may be better to run both virtual machine scale sets all the time and run full HA, but for cost effectiveness and providing a disaster recovery solution, it can be better to leave those virtual machines in a stopped and deallocated state, because when you do, you're not paying a cent for them. So essentially you can have your DR sitting in Azure Public and not pay a cent for them while they're not running, and as soon as you need them, the price metering starts to tick over. So that concludes my demo. I hope you've enjoyed it, and many thanks for all of you for attending. Cheers.